All right, welcome to Calculus. We're going to look more at series. In particular, we're going to look at convergence. I'm going to run through the ratio test in this video, and we're going to talk about how it's useful. Now, I have to recap a little bit. I have another video that goes through an example of the geometric series, an example of the P series, and also talks a little bit about the nth term test, which I didn't really do an example of because it's pretty straightforward. You're just determining whether the series itself, the individual terms themselves, are going to zero or not. And if they are not going to zero, then the series diverges. That's always the go-to place you should always start. Is this thing getting smaller as you move further down the series? Are the individual terms getting smaller? If they are, you know that you need to do other tests. If they're staying the same size or getting bigger, you're done. You know it's going to diverge. You don't have to do anything else. But let's just say that you've done the nth term test, you've looked at geometric series and the P series, and none of those things are helpful because it's not a P series or it's not a geometric series. So you know there's nothing that is going to help you move along through this. You found that the nth term test is inconclusive, so you have to move along and do something else. So I'm going to go to my go-to one, which is the ratio test. And unfortunately, I can't go through and create videos on all of these. Well, I guess I could, but that's just more time than I'm going to put in right now. Maybe I'll do them all eventually someday. So be looking for those. But the ratio test is the next one I'm going to go use. Now, the ratio test, you just look in that second column there, and it's right there. There's the ratio test itself. What we're looking for is we're going to take the next term divided by the current term as n goes off to infinity. And we're looking to see, does that equal a particular number? That's all L is. It just needs to be equal to some number. Now, what we want is if L is less than 1, then we know the series converges. If L is greater than 1, or if L is infinite, then it diverges. If L is equal to 1, then the test is inconclusive. Okay? We don't know. We have to do some other test, which will probably be the comparison test, because that'd be the next one I would normally go to. It's a pretty straightforward and easy one to do. In between these four, geometric, P-series, ratio, and comparison tests, you will be able to knock out probably 95% of all of them that you need to do. Now, so here's the series we're looking at. So we have 3 to the k power and k factorial. All right, so we're writing this as what would be a rational function, except we're dealing with series, so this means it's discrete. It's not a function that's in particular values. They're just kind of blocked out, right? So what do we do with this? Well, 3 to the k, that looks familiar. That looks like a geometric series, except I'm then dividing by k factorial. So what does that do? I will tell you that when you write these out, you can pause the video and just plug this in. Plug k equal to 1, k equal to 2, k equal to 3, k equal to 4. And what you will find is that these values are going to, it may take a little while, but these values actually will start to get smaller, which means we don't know whether it diverges or converges. All we know is that the nth term test is inconclusive. So we're going to do the ratio test, okay? Which means I'm going to take the limit as n goes to infinity, right? K, actually, I guess in this term, right? Since I'm using k's here, I'll write this as a k. As k goes to infinity, I'm going to do the next term, which is 3 to the k plus 1 over k plus 1 factorial divided by 3 to the k over k factorial. Now, some of you are looking at this thinking, this looks horrible. Why did I choose to do this? Why do I care? Well, those are a different video. Let's just answer this question right now, okay? So what do we do with this? That's the next question we really need to deal with. So the thing you need to remember is that when we say factorial, like 5 factorial, means that you have 5 times 4 factorial. That's the important thing you got to remember here, which means that if you're talking about k plus 1 quantity factorial, that is the same thing as k plus 1 times k factorial. That's a pretty important thing to remember, okay? If you don't see it already, I'll show you here in a second. And then also the other piece to remember is that when you have 3 to the k plus 1, that's the same thing as 3 to the k times 3. Now maybe some of you are going to start to see what's happening here. You might want to pause and see if you can work in front of me for a moment, right? So let's just do this. You got k going to infinity, right? And then we're going to have 3 to the k times 3 over k plus 1 times k factorial. And I'm going to multiply by the reciprocal of the denominator. So I have k factorial, and then I have 3 to the k. Now, if you didn't see it before, hopefully you see it now. These two pieces right here, 3 to the k's cancel, the k factorials cancel, and you're left with the limit as k goes to infinity of 3 over k plus 1, which is equal to 0. Now, if you're like, how does that equal 0? You're doing k is getting bigger and bigger and bigger, which means you're doing 3 divided by a really big number, and then that number is getting bigger, so that entire thing is going off to 0. Now, look at your rule. Ratio test told us we do the next term divided by the current term, so we did that. We plugged in n plus 1, or k plus 1 in my instance, and my value of L is what I'm concerned with. My value for L in this instance was less than 1. So here's my L value, and L is equal to 0, which is less than 1, which means it converges. Right? Well, hot diggity dog, right? There we go, and that's all we were doing. That's what we're trying to find. And what you will discover as you work more of these is that you'll run into the same idea. So just kind of a pushback on doing the P-series and geometric series. If you see a factorial in that series, and they occur quite a bit, and if you're wondering why do they occur so much, well, that has to do with how we end up building some of the series that we need to work with. And factorials come into play quite a bit with that. But if you see a factorial in the series, you automatically know that ratio test is probably the place you need to go to, because the ratio test allows you to cancel out factorials so very quickly and easily. Then you might have to deploy some other techniques to deal with the limit, but normally it gets you to where you want to go. In those rare instances where it equals 1, then you need to go to something else, maybe like the comparison test, which is a little less intuitive. It takes a little bit more forethought in building it up, but it is pretty straightforward after that. All right, take care. I hope you're enjoying series. I hope you keep working on math and just move forward at all times. Take care.